look at the microphone.
Just look at it and goes, ah!
Hey, folks. Welcome to the security table where Izar is looking at his microphone, which I don't think makes it work any better, but it's a place to start. It's a new day. A new day is
my
dawning.
My microphone is here. I should be looking here.
That's called a monocle. And you could totally rock the monocle if you went for it.
I can't take my glasses off because otherwise I poke myself in the eye with my monocle.
Well, we are a safety first organization here, so please do not take out an eye with a monocle. All right. Well, the topic of the day is a paper that's just been released that is encapsulating a pretty big issue that's going to impact cybersecurity for pretty much ever from this point forward. And the name of the paper is The AI Vulnerability Storm, Building a Mythos-Ready Security Program. And so between Mythos and Project Glasswing, Mythos being this new Anthropic model, which is good at finding vulnerabilities. It's a little bit too good at finding vulnerabilities in systems and creating exploits. And then Project Glasswing is the collective of various organizations coming together to share information under this heading of AI-generated exploits. So that's kind of the setup, I guess, of what I understand about Mythos and Glasswing. What is this paper trying to do? Like, what's their goal? Anybody able to figure that out?
I think that the first big goal here is that they are setting up the next war between GIF or GIF. Is it Mythos? What?
It's mythical.
It's mythical.
Remember the mythical man month?
Yep.
Now this is the mythical LLM day.
So is it Mythos? Somebody
It depends. Are you Greek or are you?
Oh, that's a very good point.
You could ask Gemini or something to pronounce it for you.
It's just going to laugh at my accent. I know it. That they're getting too smart. But actually, the Mythos here. Okay, I'm going to go with Mythos. So the Mythos here, just to keep on the Greek theme, is setting up the next Sisyphus effort. If people are not familiar with my accent or with Sisyphus, it's that guy that is condemned to roll the big rock up the mountain just to see it fall on the other side, and then he has to start again and again and again.
Is it better to be Sisyphus or Daedalus?
Oh, wow. Or Prometheus, the guy with the ego packing on the liver. Yeah. that
Lots of doom and gloom in the Greek mythology. It's like,
man, the Greek had a lot of time in their hands. Like, whoa.
All I did was sit around and like philosophize, right?
Right.
I can't say that. Wow. I'm sure they had linguists too, but
you got it right the first time.
I did philosophize.
Yeah. Philosophize on something.
Wow.
Actually, I could sign up for that job.
You'd have to wear a toga.
Just sit down. Oh, I can rock a toga, but just sit down and philosophize. Sounds good. Okay, let's philosophize a bit here. So, full disclaimer.
Is Socrates?
I have read up just to the executive summary, and they were very nice to give us a point by point, blow by blow play.
Well, we should say this is a paper in draft form.
Oh, yeah.
Provided under common something, non-commercial, common CC, whatever. By CISA, not by CISA, by the former director of CISA.
Cloud Security Alliance is kind of the
CSA.
collective plus Gen AI Security Project at OWASP.
Yeah, I always
this is a community effort
between CSA and CISA. And what a community it is! Because we got names like Jen Esterly, our beloved Bruce Schneier, Phil Venables, who else I recognize here?
Katie Masuris.
Katie, thank you. who else? Rob Joyce, of course, and Gadi Evron, who's been doing a huge job with AI lately, AI security lately. And yeah, I'm
Rob,
sorry, but I'm bad at names. These are the names that I
Rob Van Den
remember.
Veer is on here.
Oh yeah, definitely. But
And
gotta put it out there.
the whole team over there in Sands, right? Ed Scudis and others.
Yeah, but just I was telling you guys before, just like starting to scroll through the pages, I get to the authors and contributing authors one, and I'm like, whoa, okay, I can't say a single word against this thing because no, like this huge brain trust right here in page 2 probably didn't leave anything to be a question. So let's close shop and go home.
Yeah, there's always time to question. I mean,
Yeah.
I kind of read it. I guess I interpret it a little bit differently in that this is likely the existential problem of the intersection of cybersecurity and AI for the next 5 years. So it is getting a lot of attention. It's getting a lot of people are thinking about it because we've reached the point where AI can break stuff at a 100x time faster speed than humans can, maybe even more than 100x.
So I'm going to agree with that, but with a slight aside. In the past few years, which as we know in AI technology terms are decades, we have seen many times something hyped up, not something declared, and then when we got to look under the hood, it was all of a sudden, it was in these conditions, but not those conditions, and the wind was going in the right direction, the moon was in the right place. Apart from a very select number of people, nobody has actually seen these results and measured and tried and reproduced results and things like that.
Well, and just to highlight it on page 10, it does actually talk about the Mythos experience. Internal testing at Anthropic showed Mythos generated 181 working exploits against Firefox, whereas Claude Opus 4.6 only had 2 under the same conditions. So
What was the opening? What was the opening of that sentence?
100 Mythos generated 181 working exploits.
The opening before that.
Internal testing at Anthropic.
By whom? At Anthropic. Who produces both models?
Anthropic.
Who are we paying when we use both models?
What are you getting at here, sir?
Dad, I'm going to need something a bit more independent before I run away with this.
Sure. I'll keep looking, but so far, 181 working exploits against a web browser. So you're talking about JavaScript engine and a HTML processor.
Oh yeah, sure.
Yeah, and I mean, if you go to the timeline, Izar, I mean, there is more data to back up page 12. February 5th, 2026, Anthropic using Claude Opus 4.6 reported 500 plus high severity vulnerabilities in open source software.
Look, I'm not saying that this is bullshit. I'm just saying that there have been instances in the past where things got propped up to a certain level, only then to fall down from a cliff when people look closer.
But I mean, I think we can all admit the fact that even if this isn't it is bad. Coming. It is coming, yes. Though. It's like it's even if this isn't all that they're saying it is, the technology is moving in this direction, and within 1 to 2 years, this will be a reality where this model will no longer be in preview only. People, nation states, other organizations are going to have access to this, and this is going to change the game on it's going to drive software security to be resolved, or people are going to go out of business.
As it is well known by now, I am not a fighter pilot, but I play one on the internet. So the thing is, for years and years and years and forever, people have been looking at that thing called the OODA loop, the Observe, Orient, Decide, Act loop in cybersecurity. And the way that it connects to my joystick is that it came from the military, from fighter pilots, in saying that in a dogfight, the pilot with the smallest OODA loop, the pilot that's capable to observe, orient, decide, and act in the shortest amount of time, is the one that wins the fight, because they can react and predict and act much faster than their opponents. And we have been seeing the same argument applied to cybersecurity for many years. And to me, what this whole thing now with AI means is that the OODA loops are getting, extremely compressed. Where things get different, and I think that this paper brings that up very well, is the first three phases: the observe, orient, decide. Those three, they scale together, both the attacker and the defender. Using AI, they can make those things go faster. Where things get bogged for me is the act, because for the attacker, acting is releasing the attack, pointing it, firing it, and out it goes. For the defender, the act is patch these things before the attack comes in. And
by the
again,
way, you're assuming the patch exists.
Yes.
That you're
yes, thank you
assuming
very
the patch works, and you're assuming that there isn't a bypass.
Exactly. Thank you. Which are all amplifiers of that time scale for the defender, right? So I was very surprised when I saw in the page.
Oh, I know. By the way,
0.
you hope the patch doesn't break something else.
That
Because
too.
you have that too.
And you hope that the IT people, who are not the security people, who actually say, yeah, okay, we're going to put the patch in place, don't have their own processes that take oodles of time on top of that.
Oodles of time for the OODA?
Oodles for the OODA.
A lot of OODA this morning.
A lot of OODing,
Yep.
yeah. Turn it into verb.
Okay. So the thing is, so the paper says that what to do now to deal with the current risk spike, that is, what to do now to deal with the attacker OODA loop being so compressed. Adjust risk calculations and reorient security program resources for increasing volume of patches, decreasing time to patch, and more persistent complex attacks. Nobody thought of this before, I guess, right? It's news. It's okay. What do I do now? It's Monday morning. What do I do now?
You panic first, ask questions
Always.
later.
Where's my towel?
Panic.
Where's my towel?
Forget that keep calm and patch on thing. You gotta panic first.
Focus on the basics and harden your environment further. Here I'm going to open a parenthesis. Lately, I've been hearing this a lot from my boss, Uri Friedman, with the security brutalism thing that I already told you guys about. Going back to the basics is the only thing that you can do, right? I mean, reduce your attack surface and then you don't have to patch anything.
So how far back? So let's be careful about, let's be cognizant of this. How far back? I'm thinking, are we back into there's a perimeter and a network segmentation as opposed to everything is open all the time?
Well, get the perimeter reduction, put it together, zero trust, and every single thing becomes its own perimeter.
That's the theory, but that's why you have to patch everything, because everything is its own perimeter.
Yes.
As opposed to network segmentation, where you literally wall off parts of your network.
Exactly, but that's the thing. Network segmentation also depends on the implementation of a TCP/IP stack, which could have its own bugs. So you could be trusting a segmentation that actually doesn't exist. But the moment you start looking at it as a simplification of everything, and instead of just patching everything, you start taking a more critical look at saying, do I really need this thing?
Reduction first.
Is everything that's in my attack surface, is it just fluff, or does it have a practical purpose? And that's something that we don't like to do.
But that's what we do during threat modeling, to some extent.
That's what we do during threat modeling, because threat modeling is the answer to everything. Right? So I could call threat modeling 4G2 and it would sound the same. That's 2 Hitchhiker Guide to the Galaxy references in less than 5 minutes. I want a bonus. So
sure, we'll give you that $0 bonus on top of the $0 we pay you.
Thank you. So my point, and actually Uri's point, is that before you do all the acting panic run around, just reduce the frigging attack surface. Chances are you don't need everything that you need. Look at the plumbing, make the plumbing simpler before before you go make it shinier. Right?
And before you think of and just to extend that, I guess a little bit, if you think that one of those targets is useless, it's always useful to an attacker because
Exactly.
pivoting and APTs exist.
And that's one of the things this paper is highlighting is that Mythos is chaining together vulnerabilities.
Right.
So it's not just finding critical 0-day style exploits. It's doing a lot of vulnerability chaining to get these results.
Right. And so those relatively low severity vulnerabilities that had very little, impact as a result, malware authors aren't using them to necessarily, do ransomware attacks. Mythos is able to chain those together to gain a foothold or to gain little bits of information about memory or whatever, right?
So basically what you guys are pointing at right now in my head is that we used to use things like CVSS to say that something was a medium problem because the complexity was high. And Mythos can just be able to reduce that complexity so that what was medium yesterday becomes high and critical today.
There's a metric in CVSS4 though, which is not just the complexity of the exploit, which would be something that Mythos can reduce, but conditions on the attack, which Mythos can't control.
True, but those are mostly fixed because a given piece of software has a given way of being installed.
Agreed, but it's variable by install. In other words, it's fixed based on there's a cap to that because of the way the software or system, not just software, right, may be utilized or may have been developed and recommended to be installed. But then as each company and their organization, then they create a specific deployment that may be variable across deployments.
So does CVSS even matter in this new world of Mythos generated vulnerabilities?
That's an interesting question.
I think it matters. That's an interesting question. In my opinion, it just means that the scale now is going to slide, but I'm very curious to see where Matt was going.
So I guess on the one hand, it's still, I think, valuable in terms of understanding how bad a vulnerability could be, because there's more than just simply exploitability in that metric. So there is that, I guess. But if everything is critical, nothing is critical. But Mythos doesn't make a vulnerability critical. Mythos makes a vulnerability easy. And so it doesn't change its severity. It reduces some of the factors. It reduces some of the factors involved in determining that severity, at least under CVSS. But it doesn't change everything about the vulnerability. So I think the vulnerability calculation is still useful. I might ask an alternative question: what's the value of EPSS, exploitability prediction scoring?
True.
If everything is exploitable, it's always 1.
Yeah. So
True.
so it just doesn't matter anymore if
But
AI
one
can
observation
determine. Go ahead.
one observation on top of that is that we are assuming that everybody has access to something like Mythos, right? Which is probably not going to be true.
Well, it's interesting. I'm looking at the table on starting on page 17, a Mythos Ready Security Program risk register. And number 1 is accelerated threat exploitation. AI models have been discovering vulnerabilities for over a year. Mythos accelerates it, but the capability predates it.
Yes.
So that means if it's not Mythos, it's something else.
Yes, but
And it's going to get rolled into the core models. It's just a matter of time.
I don't know. The moment that this amount of red lights start showing up, people go up and say, okay, this is a nuclear weapon level thing. We need to control it. And sure, there will be escapes. There will be other people reproducing parts of it and this and that and the other one. And there will be some kid buying plutonium on eBay and building their own reactor and whatever. But at the end of the day, if somebody decides that they need a very good reason to regulate access to something like this is it. This is basically a bunch of people very, very, very high in the industry saying we need controls over this because otherwise it's going to be hell on earth.
Yeah, but we have
they never actually said that in the paper, though.
We have governments
putting words in their mouth.
We have governments which are actively funding this type of research, right? So it's not going to. This is a commercial enterprise, right? Mythos is a commercial company. They have profit and loss margins to worry about.
Well, Anthropic is
they just got
company.
blacklisted by the government, by the U.S. government, right?
But to Chris' point, yes, I'm putting words in their mouths. That's true. But what I'm interpreting here is a lot of people that we have learned to really listen to because they have had repeated successes in the things that they have predicted are now predicting something that we as an industry have always put forward as one of the big blockers, which is the time to patch. And they're saying, hey, the only way that you can solve this thing is by raising this other thing that you always said that is very difficult.
Yeah, no, it does say.
In other words, there's no. In other words, there's no solution.
Yeah, it does say non-frontier open weight models can already achieve much of this at an accessible cost. Right, frontier models are acceleration, not the starting gun.
Exactly.
And each patch also becomes an exploit blueprint. So this is something we've known for a long time, that when patches come out, they get reverse engineered and the attackers know what's being patched. Because you can't hide it, right? I mean, you really can't. You can't really obfuscate a patch well enough, unless you encrypt every patch, and it's perfect encryption. And only the systems that can apply the patch can decrypt it. If a bunch of ifs, right? Yeah. So patches contain exploits. Patches contain information that exploit writers can use, and we know that LLMs are great at decompiling.
Now, another interesting thing in here for me is I just got to the table with the priority actions. The priority actions, the defensive ones themselves, are extremely dependent on LLMs, right? They're saying turn agents and LLM capabilities inward on your own code and dependencies. That there is a big assumption in here that the solutions that we have had up to now, for example, reading code, are just not enough anymore. You need to have an LLM-based one.
Well, that's number 2, require AI agent adoption.
But that's on the writing. That's on the writing new code. The first one that they say is, take an LLM-based scanner, turn it into your code right now. Basically, in my head, what it means is you can only fight fire with fire. So if the problem is an attacking LLM, you have to have a defensive LLM.
If why an AI is generating 500, let's just assume that it is in fact able to generate 500 critical, proven, remotely exploitable vulnerabilities against your product. It would take humans a year to fix that, to patch that.
So their solution is turn your LLM scanners now into your code. A, as if people haven't been doing this already.
Okay.
B, as if we don't have the non-LLM scanners working already. And C, as if magically right now, these scanners that didn't find something before are going to start finding things just because Mythos. They are still the same models. They are still the same things.
It's calling out non-Mythos LLMs here, agents, right?
Right.
So, and including some open source ones, which is good actually to see.
Correct. It's awesome. It's awesome, right? But to say that this is a critical thing to do this week, because otherwise, I'm failing to see here how the proposed solution is any better than just keep doing what you should already be doing anyway.
Okay, so you're saying your argument is that people should have already been doing this before this paper was ever written, or they're already doing it in reality?
No, my argument is, I think, two-headed. A, that this is not something that people should start doing because they should already be doing it. But B, more important, just because a more capable model came up with a bunch of findings doesn't mean that less capable models that existed before all of a sudden have more weight to what they could find or not. So if you, in other words, if you were doing this thing before, using the same models, you're not going to start automatically finding things this week because Mythos found things last week. In other words, this is just something that sounds good, but it's not immediately going to give you any added value.
If you weren't already doing it, it gives you a ton of value. If you were already doing it, you're not gaining anything by doing it. You're not going to gain anything by doing it more.
Right.
By continuing to do it, I should say.
Right. And if you were not doing it before with either an LLM-based or non-LLM-based scanner, then seriously, what are you doing?
I mean, the theory goes here that the LLM scanner is better than the commercial SaaS tool.
Have we seen numbers saying that they are?
I don't know.
I'm genuinely asking.
I don't know. It's a good question.
Yeah, I don't know either.
I mean, if you had a Coverity or Fortify from ages back, right? I mean, those were high performant, very noisy, but high performant static analysis tools, right? They looked at call stacks and variable flow and the whole works, right? Are LLMs better? They're reading the code directly, whereas those SaaS tools were looking at compiler output. Now, granted, we're talking about compiled languages versus interpreted languages. Maybe the language pipelines are better or worse. I think the SaaS tool capabilities have changed over time. And of course, now we also have a plethora of supply chain attacks or dependency problems, which maybe LLMs are better at making those connections than the tools themselves.
That's the thing, the making the connections. You touched exactly at it. I would say that nowadays, if you're not using both approaches at the same time, and the specific reason why I say both is that, first of all, before the whole LLM thing came true, we already knew that we were having very, very good non-LLM scanners in terms of building all the AST, understanding the language, understanding how things are written and not, understanding the artifacts that even interpreters and compilers could put into the final code that gets deployed. But the most important thing that they give us is determinism. They do go through all the paths. They do go all the good ones, at least.
Yeah.
They visit all the branches in the tree.
When given enough resources, they do.
Exactly. Yeah. Exactly. It's resources and time. But, well, time's a resource. But once you have that shopping list, giving it to an LLM to check one by one, that's a different use case than just typing on your agent, find some vulnerabilities in my code.
Is it that simple? Really? Can I do that right now?
A, you can. B, yes, some people do that. C, no, that's not the right way of doing it. But the important thing here is that once those things come together and become one pipeline, they are much stronger than working apart, right? So again, we go back to the AI infused thing, not AI powered thing. You have to have AI helping your other tools, helping your other methodologies, and not always, in some cases, yes, but not always, substituting them altogether. So Captain Obvious, la 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 here, but things evolve. They don't always surpass each other, and don't always take one in, take one out, put one in is the best move here.
Okay,
what else do they tell us?
I'm looking at this list
of
priority actions, and something is troubling.
Okay.
Point your agents at your code, number one. Require AI agent use across your organization. Establish governance and defend your agents. So go ahead and deploy this technology that has, that which they say specifically has poor defenses in effect, right? Without agents, most tasks will be untenable, but they must be defended. Agents are not covered by existing controls and introduce both cyber defense and agentic supply risk. So make these things ubiquitous in your organization. Prepare to be attacked.
Yeah.
Miss it.
Not build your infrastructure and defenses first, then deploy.
Well, this is the AI age, Matt. Nobody has time for that.
Boy, it's not like we have to patch or anything.
Yeah. At the end of the day, I think that nobody is going to go into what's the name of those processes? The digitalization jump or whatever. Whenever everybody goes to the cloud and those massive lifts and whatnot,
Digital
nobody's going
transformation.
to. Yeah, nobody's going to go like the other way around and say,
No.
I'm still holding off on the cloud. Don't trust it.
I heard rumors.
You might be better secured than everyone else.
So just to close the loop on this list, I think this list of priority actions is fine. I mean, nobody ever takes a document like this and says, well, I better get to work. Team,
Well, you'd be
Yeah,
surprised.
you'd be
point
surprised.
agents at your code and pipelines.
Nope.
And then we have to require AI. Like people don't.
This is an action list for CISOs. That's what, because of the names and because of Mythos.
And people are just going to do this blindly.
I will predict that many companies will implement these almost verbatim.
And I'm going to predict on top of Matt's prediction 2 things. First of all, next week we're going to see some kind of standard that verbatim goes through these steps and says this is the new reality.
NIST 800-53 Rev 6,
Exactly.
the LLM version.
No, it would take them at least 5 years to write that. Come on.
And B, I want to say I want to go back to something that Matt said before the microphone went on. If anybody wants to try to implement this as is in this table, cybersecurity industry as a whole is saved, right? Because they will need so many people. Thanks, because it's countable now. Yeah, so many people to implement this thing that anybody that's sitting down in front of a computer nowadays and saying AI is going to take my job, those people are going to have new jobs real fast, right?
As framework installers.
Yeah, you're going to need so much work.
You need
to
humans
get this thing done right.
You need humans to make the decision. So number 7 is our earlier point about inventory and reduce attack surface.
Yep.
In order to do reduction, you have to make a decision. And until the agents are good at automatic targeting of systems, and understanding value of those targets, then you need a human in the loop. And you need a human. Okay. You need a human or humans in the loop who can understand the environment and what the attack surface represents and the value of those systems, as well as the value to an attacker. The AI can assist, but the human, I think, will probably be necessary, at least in the short term.
Because if your AI can do all this stuff by itself, you have different problems. But
well, yeah, I mean, a big power bill probably, and token bill.
That too. But it's fun that Matt pointed at item 7, and I went to the big text in there, and immediately something like jumped up because it's right in the middle of the thing. S-bomb jump.
That's where my eyes went to.
And I was going, wait, S-bombs, and I read the whole sentence. Generate real S-bomb.
Yeah, emphasis on real S-bombs.
No. And then I went to next sentence because I was hoping that it was going to tell me what to do with the real S-bomb that I just generated. It doesn't.
No. In fact, it's backwards. You should be aggressively shutting down things, then generate your S-bomb.
And then do the S-bomb. But
it is open for public comment. We should submit that comment.
Put your comments out there. Okay, so here's the ultimate scary question.
Isolate or air gap at risk systems. It is talking about network defense.
We're going to air gap in the modern internet. We're going to air gap.
We're going to go for enclaves again. Enclaves are coming back, baby.
Yeah. Success.
Oh, remember the enclaves?
Remember the enclaves?
Remember how the enclave got popped?
Remember all the Tempest research and how you could break enclaves? Yeah.
True. That's getting really nerdy, though.
Yes, it is.
When we start getting into that level. So here's the question for you, philosophical, so that you can philosophize. to use a word that we shared earlier.
If you could spell it, that'd be awesome, but I can't.
I can.
With
I can't say it, but I can.
I can't say mythos. It's mythos.
Mythos.
With
It's
mythos.
mythos.
Mythos?
With mythos, do we reach a world where all the critical vulnerabilities are found for a product and mitigated? So there are no longer, so you have a product and it no longer has critical vulns
No.
in it.
It depends.
Why?
Some vulnerabilities are unpatchable.
Yes.
At some point, you will run out of the technical vulnerabilities, right? You'll run out of the buffer overflows.
Okay.
And you'll still be left with business logic flaws that you probably cannot patch.
Why wouldn't you be able to patch a business logic flaw?
Because it's human generated, in other words, in order to make the system useful for a target audience, there are almost certainly going to be flaws that you cannot patch.
True.
Authentication issues, authorization issues, privacy problems. You're not going to necessarily be able to patch all of these.
On top of that, you're assuming that every patch works 100% and doesn't bring problems with itself. And
Right.
we have seen again and again and again that the patches work.
That's why you have AI quality assurance.
If that patch breaks major functionality, like, hey, here's how I patch this. I turn off this API. You're not going to do that.
No. But that's saying that the only way to patch is to remove functionality, right? So it's taking the worst case that you pointed out.
Right.
Yeah.
At some point, you'll run into patches that require significant modification to of the system.
Yeah, but with the way AI writes code, it operates a whole lot faster than human beings do. So it can just rewrite
and open new attack surfaces as a result.
Right, but you're assuming that every system lives in a vacuum. Systems talk to systems. If both systems don't go up at the same time, then one system could hold up the patch of the first one and say, well, if I want this functionality, I can't patch because otherwise I can't talk to the other system.
Right. This is the problem of containers, right? When you spin up and down containers, if one comes up on a different rev, you've broken your infrastructure.
It's the whole dependencies, not dependability, dependencies thing, right? Things have to move forward at the same pace that they maintain compatibility with each other.
And the big trend right now is pinning your dependencies. So even if you apply a patch, you're still not going to get the patch because
that was famous 10 years ago. Dependency pinning.
Okay, it still continues today.
Yeah.
Yes.
So number 9 on this list, I think, will require some discussion, and I don't think we have time for it today, but at some point we probably should talk about it.
Wait, which one? 9?
9.
Build a deception capability.
Yeah. So bring on the Decepticons.
So deploy canaries, honey tokens. I don't even, and actually, if you guys know what honey tokens are, let me know.
I do.
What's a honey token?
Yeah.
Unfortunately, it's like a fake password.
Oh,
or a token that gets left somewhere so that somebody can find it and then use it, and then the use of it triggers the detection.
So it basically becomes a canary. So I don't see why the distinction between both things. But the truth is, canaries, especially at the secret and credential level, are really useful. My question again comes to time. Do I deploy those things before I do the other 10, 11?
No, it says
the other two things.
It's high, so do it in the next 90 days and 6 months out.
Yeah, but then 11 is critical in the next 6 months. So how does it work? It's critical, but do it in the next 6 months.
Well,
yeah, they should have sorted this by start.
But also, what is vulnops?
It's a new ops that's going to generate a completely new industry. Watch this
I've heard
space.
that term. I've heard that term thrown around for a year or two at this point. Vulnops.
Autonomous vulnerability research and remediation. Isn't that pen testing?
No, because it's not. Pen testing is not autonomous at this point.
Not yet.
That's the car crash that we're heading towards.
staffed
Here.
and automated like DevOps, but for autonomous vulnerability research and remediation.
So
Wait,
this is a team within your development staff that just finds vulnerabilities. That used to be
It
QA.
uses
It used to be QA, you know. We used
but,
to
it
call
use,
it
but
QA.
it's using Mythos to find all those vulnerabilities before external attackers can find them.
Well, I thought your agents were doing that before when you started the program.
Somebody's
Okay,
got to
so-
run the agents. Agents aren't completely independent yet.
So you Google for vulnops. The first thing that comes up is a project on GitHub. Then the second one is domain saying vulnops coming soon. Then we have
Stand by for vulnops.
Go for vulnops.
Oh, the third one is actually a LinkedIn post that says what it is. Let's see what it is.
We could rename our podcast the Vulnops podcast.
Well, then there'd be no conflict, and we'd be the original vulnops podcast.
Well, then somebody would just copy us. Somebody would just make another podcast called the Vulnops podcast. You know how it goes.
Much like how MDR brings together a plethora of technologies to help defensive teams detect and respond to threats, vulnops does a similar job for vulnerabilities.
Okay. I'm liking
That's
it
the
so
thing.
far. I might get a T-shirt.
Yeah, but that's the thing. I don't care about being corrected. I'm used to it.
No. I'm just saying. I'm talking about this whole idea of vulnops. I think I might be in.
Yeah. No, it's just that the thing promised to tell me what it was and it didn't. So I'm still looking.
Typical AI.
No, this was normal Google.
Typical humans.
Yeah.
Humans.
Vulnerability
Can't trust humans anymore.
So at the end of this, is this something to watch or something to take action on?
Which one?
This paper.
The whole thing.
The whole thing.
Oh, no. Definitely something to watch, I think.
I think you got to take action.
But
I think you got to start rocking and rolling right now if you want to
get left behind.
Yeah, I mean, you can't roll this type of stuff out in a weekend. This is not a weekend project. This
Wait, you
is
can't vibe code your security program?
I mean, you should.
Not
Somebody
again.
should try it so we could laugh at them.
Not again. But no. I think that first of all, in my opinion, and following security brutalism, you have to go and ask yourself, why haven't I been doing half of this already? Right? Then it's the reduce. Seriously, just reduce.
Yeah.
I look around my room in here and the amount of old digital junk that I have at some point I should throw away, but sentimentality hits in and I can't. But don't be sentimental to your system.
Certainly the attack surface reduction is not a bad thing, but it doesn't solve this problem.
It doesn't solve, but in the amount of things that you need to actually fix and keep an eye on, it brings you back to fundamentals, right?
I mean, I've been preaching attack surface reduction for at least a decade at this point, and the funny thing is nobody ever does it.
No, because the more computing resources you get, the more you use.
Because budget, the more you get to buy the next shiny thing, you're going to get more budget next year, right? So it's apparently it's better to say I need $100 million to get the next shiny thing than I saved $100 million by dropping that shiny thing from last year.
Mm-hmm.
Right?
Which means on this list should have been budgets should change. Budget planning should change.
Yep, definitely.
I never talked about budget, did they?
They didn't say how much this is going to cost, right? We don't know what the token cost for Mythos is, and what the token budget is,
and how many nuclear sites we're going to have to build to power this whole thing.
Hopefully, a couple.
I'd rather build a nuclear site at this point than go back to coal mining.
True. So, what do we close with this thing? Talking point: an aggressive plan is needed.
I could say that about anything, though.
No, wait. They say
an aggressive plan is needed. About mowing my lawn, need an aggressive plan.
Wow, the funded foundation is why our program can adapt rather than react in a crisis. What has changed is the speed and volume it must absorb. Yep.
I was making up my own OODA on the fly.
OODA.
Defend your agents. Do not wait for industry governance frameworks. Define your own now.
Because that always worked.
Well,
so I guess we leave this as a wait and see.
Actually, they have a closing paragraph here that I really like. Building a Mythos-ready security program is not about reacting to one model or announcement. It is about permanently closing the gap between how fast vulnerabilities are found and how fast your organization can respond. In other words, reduce your OODA.
Does that actually say reduce your OODA, or are you just adding that in?
No, that's me. That's me.
Okay. I thought that was what I was going to hear, but I was just
that's me. Yep, that's me. And
so I mean, it's not. They're not saying anything we really disagree with at the end of the day.
No.
This is double down and make it happen. I mean,
yep. Bordering on the stuff.
And this is also, I guess I've come around on this paper. I was a little skeptical reading it to start, but it's really, if you are resistant to any of this, figure out a way to not be resistant to this.
Yes.
Because as the Borg are famous for saying, resistance is futile.
You will be assimilated.
You will be assimilated.
Oh,
I think
guys,
that's where we leave it.
I think that's Star Trek is much better for these than Star Wars, in my opinion. But
live long and prosper.
That's
right. These are the OG Spock threat modeling supermodel.
Oh yeah.
wait. You did.
Hey. It comes from the same place, right?
Right from the heart. It's from the heart.
I got membership. I got membership on the tribe. Yeah.
All right. Well, folks, we'll leave this with you here. Go basically build a whole AI vulnops program over the weekend, and we expect
reduce your attack surface before.
Reduce the attack surface before, and we expect a TPS report diagramming the whole thing.